The Arduino connector is a project that allows you to use Arduinos or Arduino-compatible boards as I/O expansion for LinuxCNC. The goal of this project is to enable you to easily build a CNC control panel or handheld MPG. Buttons, knobs, potentiometers, encoders, joysticks and matrix keyboards, RGB LEDs, PWM outputs and much more are supported by the software. They can easily be configured, and in this video series I will show you how. Hi and welcome back. I'm Alex and this is the art of tinkering. I've been often asked if the software also supports rotary encoders. Those are often used, for example, as an MPG to manually drive axes around, and so I have included it. To use encoders, you need this library here. To get it, you can click on this link, and here you can download it from GitHub. And basically just you have to download the zip file like this, and in your Arduino connector you go on include library, add zip library, and then you go to downloads and select the encoder master.zip file. And I have already installed it, but when you install it the first time, it should not give you an error like this. Okay, to use it, we have to undefine this line here. And also we have to define how many encoders we want. To show it to you, I want to use one. And down here is a list of encoders, and we have to define for each encoder the pins where the encoder is connected to. And I have decided to use just one encoder, so let's remove the second one. And now we have to attach our encoder, and for that it is recommended to use interrupt capable pins, because then the performance is best, and basically we won't have any missed steps or something like that. So ideally you would orient yourself on this list here. It has a collection of very common boards and which pins you should use. Ideally you would want to use some of those, but you can of course also use any other GPIO except the pin which is used for LED, for example. So this is not, you shouldn't use this. I'm using this old 3D printer board that I have lying around because it has on board an encoder here, and this is connected to pin 31 and 33 on the Arduino Mega. And now if I click upload, we can now see, let's have a look in the serial monitor. You can now see if I move the encoder, we can see it's changing the count. So the encoder has actually two modes that we can use. So right now it's in counting mode, which is used, for example, when you want to use it in LinuxCNC to drive around an axis. Then you could attach this counter to the axis jog counter, and that way then for each step move, for example, 1 millimeter or something, depending on the scale. But if you look down here in this variable, we can set it to a different mode, which is send up or down signal, and that can be useful if you instead would like to control the feed override, for example. I will show you how to use this now. So first thing we have to do is to change the Python script again. And here we need to go down to encoder. Here, quadrature encoders. We have 1. And the signal is a counting mode. So it's basically the same setting that we have here. We only have 1 encoder, so the second will be ignored. If we would have more encoders, then we would have to add more numbers here and also here. So these settings have to match. But for now, let's just save it and update the file on the user bin directory. And now if we load up LinuxCNC and load in the component. Okay, and now we have a new setting, which is the counter. And oops, let's see. So now if we rotate this knob, you can see it's very responsive and it updates this number. And now I can show you how to use this. So here in the axis field we have, for example, let's use this for the x-axis. And here as the jog, let's get all these jog values in. Okay, basically what we need to do is to enable the machine like this. Then axis xjog enable, set this to true. And then we need to net the axis xjog counts with the Arduino counter 0. So let's take a look. Net xjog, we create a signal and we write the value into this, and we read it from here like this. And also we have to modify the axis jog scale. So we can set this to, for example, 0.1 millimeters. And you need to be careful with this a little bit. Okay. And you see it doesn't work yet. That is because we need to home everything. So I'm in the sim environment, so the axis don't actually move. But now the axis will respond to the encoder. Okay, and if you first try this out, be a little bit careful, because this could lead to a crash if you didn't set up your LinuxCNC yet. Okay, you can also set the scale to whatever. Right now we are set to 0.1 millimeter. As you can see, if I move the encoder one position, it's moving about multiple steps. Okay, about 4 positions. So that is because the encoder actually sends out more than 1 pulse per rotation. And we can change this with the scale, but to get around this with software, there's this value here, quad encoder multiplier, and here we can define how many pulses per latch is sent out. And if we change that to 4, and let's unload LinuxCNC and update the code to the Arduino. Okay, now we can load in LinuxCNC again. Okay, and now you can see for each pulse just 1 number is updated. Okay, so if we do this again, then 1 pulse on the MPG wheel will actually move the axis 0.1 millimeter on the axis, depending on the scale. Okay, so now I will show you a second mode. So you can see, let's close LinuxCNC again. So if we change this to 1 and also change it here to 1, now instead of the counter we get 2 pins that create an up or down signal. So I'll show you here. Let's update this software on the Arduino and also the Arduino connector file. Okay, and now instead of a counter we get a counter up and a counter down signal or pin. And you can see if I turn it left, then the counter up goes high, and if I turn it down or right, the counter down gets the signal. And that we can use to, for example, modify the feed override. So let's first erase the swatch here, get our pins back, and if we go to HAL UI, feed override, there is let's get all these values in. So what we are interested in is the increase and the decrease, both of those. So let's connect them, create a signal called feed up, for example. Then we use the Arduino pin. And it is written to the increase, like this. And then we can change counter down to decrease. Like this. Okay. Hit execute. And now you can see they are matched. And if I rotate the encoder, also the feed override is moving in the allowed space. And you could also change, for example, this value here, make it smaller, and that way the you have more control to have it more precise. This is how it works. Okay, so now I will show you the next feature. Okay, I showed you how to use the quadrature encoder. Basically, the joystick uses basically the same functionality, so I will show you next. So let's remove the quadrature encoder and instead use the joystick. So as a joystick, I'm using this cheap board here. It's basically a joystick module from AliExpress, very cheap. And this has movement in 2 axes, and it also has a switch when you push it down. And it's connected to power, and it outputs 2 analog signals for the position of the joystick, and also 1 switch which can be just connected to an input, and the analog outputs will be used with an analog input pin from the Arduino. So I will connect it. Okay, it's connected with ground to ground. So basically we want to connect the power like this. And then X and Y, 2 analog pins. Here I'm using 0 and 1, like this. Okay, so let's see. Here we have, so first I undefined this line. Also, we can define how many joysticks we want. Basically, the software supports as many joysticks as you have input pins. I use A0 and A1 as input. You can also write it like this. It doesn't really matter. Yes, here we can set the middle. So if you have stick drift, which can happen with a lot of these, you can modify this parameter to the left or to the right, so that you have basically zero movement if you don't touch the stick. So let's just upload this code real quick. Okay, if we take a look at the serial monitor again, we can see that if I move the joystick, it will output a number. And this is basically, the joystick only supports counter mode. So that means that it will constantly count up. And if you take a look now, you can see that when I move it a little bit to the right, it will count very slow. And if I go to the right, it counts very quickly. It moves quite a bit. And if I go to the back again, just a little bit, then you can see it's slowly counting down. And the farther I go to the left, the quicker it will count down. Okay, and that is used for if you want to drive your axis with a joystick, then you can do a very fine movement if you just move the joystick a little bit, and it gets quicker the more you use the joystick. I can show it to you. Okay, if we go back to the Python script, you can see here is joysticks value. We go to 1. And they're connected to 0 and 1. Yes, here you can see these should match. Okay, and if we save and update the file in the user bin directory, then we can load LinuxCNC again. Okay, and now we get a counter again. These are counters for each axis. So in the x-axis we have one counter, which can, in this case, is up and down, and left and right has also a counter. And that we can connect to the jog mode of the axis. So let's clean the watch here again, get our counters back. So we want to move the x-axis, for example. So let's get the x values, the counts, and jog enable. And also the scale is important. So what we need to do is create a signal, net x jog count, for example. Then we write the value from the counter 0. That's what we're taking right now. So, and that is going to be put into this variable here, like this. And then we have to arm the machine home so that it will actually allow us to jog. Then we have to set the scale. So for example, we should use in the beginning a very small number, like this. Okay, and you can see if I'm moving the joystick now, we can also move the axis. And if I move the joystick just a little bit, tiny bit, then the axis moves very slowly. And if I go further to the right, it speeds up. Okay, so it will go very quickly if I go all the way to the left or all the way to the right. And if I just go a little bit to the right, then it will slowly creep to the right. Okay, and you can basically do the same for the x and the y axis. It's just the same code, just instead of x use y. Okay, so it's quite easy. If you don't want this feature of the axis speeding up, then you can modify this multiplayer here. So just you can play around with this number here, and this will basically scale the speed. Okay, I think that's enough for this joystick feature.